Hey guys, in this video we're going to look at how CSF circulates around the brain and how it passes through the ventricles and arachnoid space. So let's take a look at our PowerPoint slides that you have from Blackboard, and let's see how CSF circulates through the ventricles. So remember that the CSF is made in the choroid plexus, the special capillary beds that are inside the brain, and they are filtering blood and turning it into cerebrospinal fluid. And then in our last video, we saw that the lateral ventricles pass the CSF into the third ventricle. The third ventricle passes the CSF down to the fourth ventricle via the cerebral aqueduct. And now we're going to see what happens after that. After the fourth ventricle, where does that cerebrospinal fluid go? So here's a really nice diagram from your textbook, and it's showing us, number one, where the choroid plexus structures are inside the brain. So right here, this red thing you can see right here, these are the capillary beds, the choroid plexuses that are filtering the blood and making the cerebrospinal fluid, the CSF. So right here, here's your lateral ventricles. So the choroid plexus here is secreting the fluid. It's going into the lateral ventricle. Then remember, the fluid can drop through the interventricular foramen into the third ventricle, which is right here. And then from the third ventricle, the fluid travels through the cerebral aqueduct down to the fourth ventricle. And then remember, once you're in the fourth ventricle, there are several options for where the CSF can go next. It could go down the spinal cord in your central canal. It could come out one of these apertures and start circulating in the subarachnoid space of the spinal cord, or it could start circulating in the subarachnoid space of the brain. So remember, we have three layers of protective meninges. We have the pia, which is right on the brain. We have the arachnoid matter, which is the next layer. And then we have the dura mater, the tough mother, the thickest layer that's on the outside. So in between your pia mater, which would be right here, and your arachnoid matter, which is this pink line, you've got a space. It's called the subarachnoid space. So sub means under, so the subarachnoid space is a space or a compartment that's under the arachnoid mater, your layer of your meninges. So you'll notice that the CSF can come out and it can circulate all around the outside of the brain in this subarachnoid space. And remember that as it's circulating, remember it's got some good things, some oxygen, some glucose, some ions. We're going to drop off those nourishing things to the cells of the brain. But remember, the CSF also picks up waste products. So as it's circulating around, it's picking up waste products. So by the time you get up to the superior part of the brain here, the CSF has picked up a lot of nasty waste products. So we don't want to send that back around because we don't want those dangerous waste products near our precious neurons. So at this point, when you get up to the superior part of the brain, the CSF drains through this structure. It's called the arachnoid villus, and it drains into this large vein. See this blue structure here? This is a large vein called the superior sagittal sinus. Sinuses are really large blood vessels or really large veins. So the fluid is circulating around the outside of the brain. It's draining through the arachnoid villus, this little valve, and then from the arachnoid villus, it's being dumped into the superior sagittal sinus. So can you see what's happening here? We're created in the choroid plexus. It circulates through the ventricles and all around the outside of the brain. And then up here, we dump it through the arachnoid villus into the blood vessel. So every day we make about 500 mLs. So we make 500 mLs, it circulates through the system, and then we dump it. So in the system, we have about 150 mLs, and then every day we're making 500, we're dumping 500. We're making 500, we're dumping 500. So let's take a look at what could go wrong if you didn't get to dump the fluid after you were finished with it. We got some pictures of that. But just to point out, this diagram kind of takes you through the circulation here. So it tells you it goes from lateral ventricle to third ventricle, from third ventricle to fourth ventricle, from fourth ventricle into the subarachnoid space, from the subarachnoid space into the arachnoid villi, and then it gets dumped into that big vein, the superior sagittal sinus. And then the blood will take away that old dirty CSF and get rid of the waste products that are in it. So that's our pathway for circulation. So let's look at what could go wrong. So remember, we're relying on this idea that we're making it, it circulates, we dump it. We're making it, it circulates, we dump it. So if something goes wrong in the system and we don't get to circulate the CSF, it's going to build up inside the brain. Now remember, if you're a baby who's just been born, your skull bones are not fused together. Remember, we saw that in a growing baby that the brain is not fused together. We have those fibrous connections between the bones, and it gives a little bit of space for the skull to be able to expand as the brain grows and as the baby develops. So here you can see that in a baby, if you have this problem, which is called hydrocephalus, it literally means water on the brain. But what's happening here is CSF is not draining. So if we go back to our picture here, there's some kind of blockage in the system that's stopping the CSF from circulating around its usual pathway. So if we have a tumor or something right here, then our choroid plexus is still going to keep making CSF, but we can't dump it. We can't send it around the system and circulate it. So it's going to start building up inside the ventricles of the brain. And then that's going to cause the ventricles to swell up. And then that's going to start pushing against the brain. Now, the good thing is if you are a baby, that your skull can expand to accommodate this fluid. Also, if you're a baby, we're going to notice this right away. We can tell from this picture something is not right with this baby. So we can get a pretty fast diagnosis, realize that there's swelling going on with this extra fluid inside the brain, and the doctors can get in there and start to drain the extra fluid. So if it's a baby, it's kind of good in a way because you actually can diagnose the problem pretty quickly. But if this happens in an adult, remember our adult bones are fused together. We have those synostoses, those sutures holding the bones of the skull together. So there's no scope for expansion. So think about it, if you get hydrocephalus in an adult, as the fluid builds up inside the brain, or your brain is getting squashed in between the swelling of the fluid here and the bones on the outside of your skull. So this can really damage the neurons. So in an adult, remember, we're not going to see anything externally. They're going to look pretty normal from the outside, but they're probably going to have headaches, disorientation, maybe even paralysis, loss of sensation. They're going to have many and varied symptoms, and it can be really hard to work out what's wrong with this person until you get them into the MRI machine or the CAT scan to see what's actually going on inside the brain. So in a way, in a baby, you can notice this right away and you could treat it right away, whereas in an adult, it may take a little longer to diagnose. But in both cases, it's not good news because it means something is blocking that circulation of CSF. And usually the blockage is some kind of tumor or cancer tumor forming inside the brain. So you probably need some kind of surgery to try and clear the blockage. So that's the end of our next video, which was all about the circulation of the cerebrospinal fluid.